Now, have you ever watched the sort of the local news forecast and the weather person comes on and gives you the 5-day forecast and tells you if your soccer game is going to be rained out or not? Sort of fun. Turns out there's a lot of mathematics behind that. So it's not just a wall, you know, where you can sort of see the map. Oh, yes, and here is your state, and here's the big system here, and that's blowing in and coming down here, and you can see the movement here. It's not all that, but in fact, behind all of that is a lot of mathematics. Let's take a look at this example. So it turns out that meteorologists are planning the location of a new weather station to cover Santa Cruz, Morgan Hill, and Gilroy, California. Gilroy, by the way, is the garlic capital of the area. Anyway, to optimize the radar coverage, the station must be equidistant from the three cities. And they're located, if we map them on a coordinate plane, at Santa Cruz is at -5, -5. Morgan Hill is at 2, 2, and Gilroy, the garlic capital, is at 4, -2. Here is our challenge, to find the coordinates where the station should be built. Okay, well, let's take a look at the coordinate plane. And you can see I put down the cities already at their appropriate spots. And what I want to do is I want to find the one spot that is equidistant from each of these cities. That is, I want to find the point so that the distance from that point to Morgan Hill is the same as the distance from that point to Gilroy, the garlic capital of the area, and the same distance from that point to Santa Cruz. So you can see that where I put my finger actually is probably not the right answer because these two look sort of small compared to that. I probably have to slide my finger down somewhere a little bit, maybe here. This distance, and this distance still looks a little bit long. Anyway, how do you find it exactly? Well, it turns out there's this great theorem that tells us that if we're looking at a triangle and we want to find the point where, in fact, that center point that is equidistant from each of the three vertices, there's an easy way of doing it. We pick any two sides of the triangle, and on each of those sides, we construct the perpendicular bisector. If we put down the perpendicular bisector for each, then where those perpendicular bisectors intersect will actually be the point that is equidistant from each of the corners, each of the vertices. So let's begin. All right, so let's take a look at this side right here. And first of all, if we just eyeball it, I think we can see where the center is because, look, notice that, in fact, this line actually passes right along the diagonal of each of these squares. Do you see how the squares go right through it? So 1, 2, 3, 4, 5, 6, 7 squares. That means half of it's going to be 3, 1, 2, 3, and a half. So it's going to be right there. So now we know exactly the location. Exactly the location. But perpendicular. Well, we know about perpendicular. We just look for the slope to be the opposite reciprocal. Well, the slope of this line, since it goes right through this grid, we can see the slope is 1 because we go up the same distance that we go over. Up 1 over 1, up 1 over 1, up 1 over 1. So slope is 1. Opposite reciprocal is -1. So from here, we're going to start here and go down 1 over 1, down 1 over 1, down 1 over 1. And if we do that, we get this. So this is the perpendicular bisector to the Morgan Hill Santa Cruz side. Now let's take a look at this edge here, the Morgan Hill Gilroy side. Gilroy, by the way, the garlic capital of the area. Now, finding the midpoint here is actually pretty easy because you can see that here I've gone, well, this is 1, 2, 3, 4. That's 4, so half of that is 2. So I have to go 2 units down. And here I've gone 1, 2 over, so halfway between there is 1. So in fact, right here you can actually see is the midpoint. And what's the slope? Well, the slope here is I go down 2 and over 1. So the slope is -2. What's the opposite reciprocal? That's going to be 1/2. So from this point, I'm going to now do 1/2, which means I go 1, I go 1 up, and 2 over. So 1 up, 2 over. And I'm at this point. 1 up, 2 over. I'm at this point. 1 up, 2 over. Wow, I actually intersect right there. And you can see that that does, in fact, look, and is, the perpendicular bisector of this side. And you can see where they intersect. They intersect right here. You can pinpoint that point. It's -1, comma, -2. And we can actually check that that point is the same distance from Santa Cruz as it is from Morgan Hill, as it is from Gilroy, the garlic capital of the area. So it really is interesting to see that we can actually find that center. And in fact, what we see here is that if we drew a circle, starting with this as its center point and having a radius this, that circle would pass through Morgan Hill, Santa Cruz, and of course, the garlic capital of the area, Gilroy. Terrific.